have a go. So you've been told a particle of mass 2 kilograms is moving on a smooth slope, so there's no friction to worry about. It's being acted on by a force of 4 newtons, which is parallel to the slope. The slope is inclined at angle alpha, and tan alpha is 0.75. Work out the acceleration. So the fact that it's asking for acceleration means that we're probably going to end up using F equals ma, because we've got some forces given to us as well. Now, a really key thing to remember with these types of questions is this is useful. So if you've been told that tan alpha equals 0.75 or 3 over 4, we can actually draw that triangle out, and it's going to look like this. So if that's alpha, opposite over adjacent means that that's 3 and that's 4. This is a Pythagorean triple, and the hypotenuse here is going to be 5. So straight away we can work out cos alpha and sine alpha. And anytime we see cos alpha or sine alpha in the question, we can replace it with the fraction, and same with tan alpha. So if cos is a over h, that's going to be 4 over 5. And sine is o over h, so it's 3 over 5. So we're just going to keep this on the side for now, and we're going to use that information later, probably in the question. So let's get started with a sketch. We know that we have a slope. We don't know the angle. That's fine. We can work it out using sine, cos, and tan, but we're not going to need to do that. So from here, we have a angle alpha. We've got a particle of mass 2 kilograms. So the mass or the weight here is just going to be mg. So that's 2g. We know that there's a force of 4 newtons acting parallel to the slope. So in this case, the force is going to be acting in parallel to the slope, and it's 4 newtons. So we want to figure out how much it's going to accelerate. There are some forces that still have to be written here, so we have to mention the reaction force, the normal reaction, R, and we also need to just show the fact that it's accelerating using a double-headed arrow. So there's some acceleration, we're just going to call it acceleration, ACC. So telling the examiner that how we're resolving this, we are going to just do this R and then an arrow. So we are now resolving along the slope. The first thing we would like to do here is resolve this 4 Newton force. Or actually, let's do the 2g first. So the 2g force can be split into this component and then this component here. So that's a right angle. It's not very well drawn. Let me just do that again. So you have a right angle here for this 2g force. And we know that this angle here is alpha. So this would be 2g cos alpha. Now going back to our first point here, we know that cos alpha is just 4/5. So in other words, this is 2g times 4/5, which just becomes 2 times 4 over 5, so it's 8/5 g, 8 over 5 g. And then the other component here is just going to be 2g sine alpha, which is 2g, and then sine alpha, from what we remember before, is going to be 3 over 5. So this is going to be 2g times 3/5, which is 6g over 5. So, and that is a force, so it's just going to be newtons, both of those. We've now resolved the 2g force. There aren't any other forces to resolve. We should just be aware that reaction is going to equal 2g cos alpha, or in this case 8 over 5g newtons. That's what the reaction is. We don't need to work that out. That's in equilibrium. And then parallel to the slope, we're going to have to take these away by subtracting them, and then using the formula F equals ma. So let's work this out. So using F equals ma, we have 4n, and then the opposite, oh, I don't need n, so let me just clear this up a bit. So we have 4n And so F equals ma 4 minus 6g over 5 is equal to mass, which is 2, not 2g, it's just 2 times acceleration, and we don't know what acceleration is. So we're just going to rearrange this, and that's going to tidy up to give us our answer. So you put this in a calculator in this case. So 4 take away 6g, 6/5 g, all divided by 2 is equal to a. And if you put this in a calculator, you should get, so let me put this in. Okay, so on a calculator, you end up with negative 3.88 exactly. Now, this is an acceleration. So in this case, it's actually decelerating at a rate of 3.88 meters per second squared. So you can either say it's decelerating at 3.88 or accelerating at negative 3.88. In either way, the acceleration is slowing down. So